Hi, this is Kona, and for this video we're going to talk about normal distribution and some things that go along with it. Remember, this is just a supplement to the things that you should have already read in your notes in your book. So the normal distribution is just a mathematical curve that provides a good model of the relative frequency distributions. So this is basically a curve for if your data is a normal distribution, so like heights of people or weight of people, the data is going to kind of form this normal curve. So it's just kind of, people also call it a bell-shaped curve, and that's a normal distribution is a bell-shaped curve, and that's just meaning that most people aren't going to be in the middle. So most people, and this is, remember, this is your average, this is your mean. So most people are going to be in the mean. So this is higher. This is saying more people are in the mean or average. So like I'm 5'5", so I would be pretty close to average in height if this was women's height. But then you've got people who are way over here, so this is really short people. So for example, I've got a friend who also teaches at Richland, Jill Feinstein, if you know her, and I think she's not even 5 foot tall, so she would be way over here, so she would be in the minority, where I'm kind of in the majority. But then I also have a friend who's 5'10", and she would be closer over here into the minority, but on this side. So you've got the median, the middle, and then you've got over here, you've got people who aren't as likely to happen, and over here, other people who are less likely to happen. But these are the people who are above the mean, and these are the people who are below the mean. So this is the left tail. So remember when we talked about left tail and right tail, where here's the left tail, and here's the right tail. The right tail is the more than, so people who are more than this middle, and this is the left tail, and these are people who are less than the middle, or if not people, then whatever you're measuring. But here's your middle, here's your average. These are people who are more, these are people who are less than your average. So properties of a normal distribution, it's unimodal, which means there's only one mode. So that's right up here, and that's where your mean, median, mode are all the same. It's the most frequently observed value of x, is that the value of x falling exactly in the mean. It is bell-shaped curve, which I talked about. It is symmetric, so that means you could technically take this and fold it in half this way, and it would be symmetric about the mean. So they have a mirror image, and mean, median, mode are all equal, which I already said. Conditions that must be met for a normal distribution. Observations in the sample must be independent, and independence is guaranteed when we take a random sample from a population. It can also be guaranteed if we randomly divide individuals into treatment and control groups. So this is really important because for your quiz you're going to be asked, is it independent or dependent? And independent just means that it has to be a random sample, or you have to be dividing people randomly into different treatment control groups, but you can't let people pick themselves where they want to go. The other condition that must be met is the sample large enough? So you've got expected cases divided by cases must be at least 5 or more, or observed counts divided by cases must be at least 10 or more. So the formula for finding the value to compare this with is just the number, so the total number of cases or people in the sample times the smallest frequency. And that might not make much sense, but we're going to get to an example that will hopefully make that make more sense. A few other things to note about the normal distribution. Not all are unimodal, but most are. The area under the curve must equal to 1. This will actually become more important next week, but just kind of remember the area under the curve must equal 1. The standard normal distribution, your mean is your mu, which is 0. Standard deviation is 1. And it's also normally transformed into z-scores. Sorry, I couldn't talk. The z-scores are the thing that we will get to next week. So just kind of something to think about. So don't worry about anything here right now this week, but for next week, we'll be thinking about this. So for our examples, 200 people walking out of a heavy metal concert were surveyed about their political affiliation. Results show 9% were Democrat, 5% were Republican, 86% were independent. What's the lowest observed frequency? So this is an observed frequency just because we already have the results here, and it was an observation, right? Because we just asked them, we didn't kind of experiment on them. So our N was 200. Our smallest frequency is this 5% right here. We turn the 5% into a decimal and to find our lowest observed frequency. So we do 200, which is that N, times our 0.05% to equal 10. So does this meet the large enough condition for a normal distribution? Why not? Well, remember the largest enough thing is right here, the conditions that must be met. And observed must be at least 10 or more. And here our lowest observed frequency is 10 or more. So does it meet the large enough condition? Yes, because it is at least 10. Does it meet the independent condition for our normal distribution? Why not? Well, no, it doesn't, because it wasn't a random sample, so that means it's dependent, not independent. And why wasn't it random? Because you observed people. You just saw people walking out of the concert and you said, hey, what's your political affiliation? Well, this was completely not randomized. That would be like going to a Trump rally and asking them who they're going to vote for. Well, I'm betting almost 100% are going to say they're voting for Trump. It's not randomized. So for this one, it's not independent because it's not randomized. So this would not be, because we wanted to know conditions that must be met for a normal distribution. So for this one, even though it met the large enough condition, it did not meet the independent condition. So yes on this one, no on this one. So example 2, National Random Survey of U.S. finds the following for political affiliation: 26.3 are Republican, 30.3 are Democrat, and 43.3 are Independent. So if we randomly survey 200 people, what's the smallest expected frequency? So for this one, you're being given data, so you're being given percentages, and then they want to know if we randomly survey 200 people, what would we expect the frequency to be, the smallest expected frequency? So in this case, we do 200 because that's how many people we're going to randomly survey. Then our smallest frequency would just be we come in and find the smallest frequency. I will give you a hint that on the quiz, they might not give you all of the percentages. They might only give you 2 of the percentages, and you might have to actually subtract from 100 to get that last percentage. But in this case, they're giving you the 26.3, which is 0.263. So to get that smallest expected frequency, we just take the n 200 times the 0.263 to get the 52.6. And does this meet the large enough condition for a normal distribution? Why, yes, it does, because it's way more than 5. So we're good there. But does it meet the independent condition? Why or why not? And yes, it does, because it's a random sample, so it's not dependent. And we know that because we actually have in here, it says, if we randomly survey. So, yep, it is random because we said it's randomly surveyed. So I hope this helped. Just remember this is a supplement, so make sure to read the textbook and your notes. But I hope this helped.